All right, let's get started. Okay, so already starting early, got a slight typo there. Let's change that to week 4. Okay, week 5, everybody. If you recall, first off, if you recall from the syllabus, this is week 5. What happens during week 6? We have our first exam. Of course, we don't have exams in college. We have celebrations of learning. So we're going to be celebrating on Wednesday, February 19th. So Monday, we're going to have a review day. So the way that we're going to do the review is I'll go through generally what is supposed to be on the exam, and then I'll give you a sort of exam practice so you can kind of get an idea of what the exam will be like. The exam itself will be pretty much just like that, just a little bit longer, because I'll be taking up time during the review to answer any questions everybody has. The first CAD assignment was graded. Grade was, average grade was like a 46.7 out of 50. So you all as a class did very, very well. The assignment that's due today at 5 p.m. As of this morning, about, I'd say 2/3 of you had submitted, which means 1/3 of you still have to get that in by 5 p.m. today. Does anybody have any big questions about assignment 4? Everybody, so far so good? Okay. Today what we're going to do is maybe slightly different than what we've done before for a couple reasons. But I'll say a couple things about our topics for today. First off, I'll just level with you. So over the past couple weeks, I've been showing you the various associated commands and tabs and whatnot in order to be able to produce objects for drawings. And don't get me wrong, I use that stuff all the time. But without what we're talking about today, I'd probably lose my mind. In fact, while you all are just learning CAD, at least for me for the past couple weeks, I felt like I've been walking through mud. And what I'm getting at is, once you start learning how to use editing commands and modifying commands, your work in AutoCAD will go light speed, okay? So being able to copy objects, rotate objects, scale objects, trim, extend, all that, just the act of moving an object, just being able to do that, it will open up a whole new world of CAD for you, and you'll understand this week. These are our main commands for today. So we've got 3 goals. We're going to edit some objects, modify some objects. We're going to create text. We haven't done that yet. We're going to do text in AutoCAD, and we're going to plot. We're going to learn how to print appropriately in AutoCAD today. Okay. Handouts are up here if you haven't already gotten one. And QR codes here if you missed it. Now, today is a little different in that instead of starting with a fresh drawing, I want you to download a drawing that is on Blackboard. Okay? So if you open Blackboard and you go to week 5, okay, you should see 2 tutorial drawings. I want you to download those. Okay? If you're using Cameo, you need to take those, stick them in your OneDrive so that you can open them. If not, just stick them anywhere on your computer and open these in AutoCAD. And what you should see for this first drawing is you should see this grid of like 8 different regions, and each one of these regions are dedicated to a modification command. Okay? And so we're going to use those commands today, and we're sort of going to walk across this panel one by one and show you how all these work. I'm going to give everybody a second to get these open, okay? Because, again, I think you'll see CAD is really fast with this, okay?
And you said it's also on Blackboard?
They are on under tutorial in week 5. Yes, if you go to the tutorial section, you should see this handout as a PDF, but you should also see 2 tutorial drawings. We're going to use both of those today. All right. Does everybody have this open? Does everybody have this open? Anybody having major issues? It's okay if you are. okay? And we're going to go ahead and move forward. So what we're going to do is we're going to start at the top left, and we're just going to work our way across, okay? A couple things about this drawing, not that it's like really important for all of you, but you should see I've got several layers created. I've got one for annotations, one for the boundary, one for the construction. What we're interested in primarily are the objects themselves. Okay, so let's start with the move and copy objects. Okay, I grouped these together because in AutoCAD they operate pretty much the same way. Okay, now the way that you move an object, so I want it to be clear. Okay, there is a difference between moving and hold on. There is a difference between moving and panning. Okay, panning is just pressing in with your mouse wheel and sort of shifting where the camera is, but it's not the same thing as moving. Panning is sort of like what I'm doing right now in the room. I'm walking around the room. Okay, this table is not moving. It's sitting right here. Okay, this is me panning. Moving would be actually picking up the table and translating it to a different position in the room. So how do we do that? Let's start off with move. Okay. Now these commands have several steps. Okay. So the first thing that we're going to do is select an object. So again, you could select objects, any way. I'm going to select this first square. Okay. And then to move on to the next phase of the command, you can either press Enter or right-click. And then what it asks you for is a base point. Okay. Now to explain what that means, what I'm going to do is just click a corner here of the square, like click this top corner, click, and I can move it. Now by the way, that movement command, I did that movement command with the mouse. I could very easily have said @6 less than 120 or #2, 4. I could have very easily applied precision here as I do with all other commands. Now what I did with this command is I selected a base point that was on the shape. That doesn't necessarily have to be the case. For example, if I do it again, move this object and select a base point, like let's say I put one over here, it will translate and use that point as the reference. Okay? And that's sometimes kind of nice if you're editing objects. Okay? Is everybody being able to do this? So watch this. If you're able to move, then you're able to copy. Because to copy, it works the same way. The only difference is that when you run the move command, once you move it, the command terminates. Whereas with the copy command, I can click a base point, and I can just keep on making copies. I can make all sorts of copies. And the command won't end until I tell it to end. Pop quiz, what do you think is the easiest way to end the copy command? The escape key. I told you the escape key is going to be your friend in this class. You can just hit escape. And I can do the same thing over here. I can copy an object. And by the way, the copy command, you can see in here under modify, here up here on the top, or on the left for those of you using Mac. The modification commands are going to be grouped there as well. Okay? So I can click the copy command, select a point that is not on the base or on the shape, and works the same way. And again, just like with the move command, I can say @6 less than 40, @6, 3, #5, 4. I can do whichever I want. Okay? Are you already starting to have thoughts in your head about how some of these past couple homeworks would have been a lot easier with move and copy? Starting to make sense? When I said I was walking through mud, now you kind of get what I was talking about. Okay. Any questions on move and copy? Everybody good? So let's move to the right. Let's go to rotate. Okay. So I've got 3 options for the rotate command. Okay? I have what's called base point on the shape, base point off the shape, and what I'm calling using a reference. Okay? So let's do base point on the shape first. So I'm going to do rotate. Just type it in. We're going to select this square over here. I'm going to zoom into the square. So we're going to select this square. And I'm going to pick this bottom corner. So we'll pick a point that's on the shape, a base point. Now look what happens. Watch what happens when I take my mouse out here. Now I can rotate it. Now I could rotate a number of different ways. I could just click on the screen. I could type in a rotation angle of 30 degrees. However we want. Let's just click on the screen for this one. Let's just click here. Okay? How does it work when the base point is not on the shape? Let's try that. So rotate. Let's pick the square, right click, and then let's pick a point, I don't know, like right here. So when I do that, look what it does. It treats that as think of that point as sort of the center of the circle about which we're rotating. Does everybody kind of see that? Now with this, I'm going to enter a value. Let's enter a value of 30. 30 degrees. Boom. Does that make sense? Everybody, is this all working? Everybody having any issues with this? Okay. How about this? How about this reference? What am I talking about here? Sometimes whenever you're drawing in AutoCAD, what you really want to do is align objects. So let me show you how this works. This is the best way that I kind of like to describe it. So we use rotate. Okay, I'm going to select an object, and everybody watch up here. So I select the object, right click. It asks for a base point. I'm going to pick this bottom corner right here, and then instead of picking an angle, look at the bottom. See where it says copy or reference? I'm going to type in R for reference. Okay, and watch what I'm going to do. My reference is going to be a line going from here to here. So from opposing corners. Now, when I specify a rotation angle, it's starting not at the horizontal, but it's starting from here. So maybe what I want to do is align this to some particular point in my part, and I want to align it to where those axes are together. So my reference will be that diagonal line along the square. Does that make sense? So the idea is that instead of rotating from just the horizontal positive x-axis, I can rotate using my reference datum as whatever axis I want. Okay. So we'll just click maybe, I don't know, over there. Okay. I don't want to go too fast with this. So does anybody have any questions? Is this all good? Everybody back up here? Everybody doing good? Everybody on this side doing good? Okay. Let's look at scaling. So the way that the scale command works is it will take every vectorized object that you create in CAD and you select for this command, and it will augment or shrink those objects to a specified linear scale. Okay? So for example, let's say this square here on the left, I'm going to use the scale command, which again, for every one of these commands, there's a button over here, so I'll hit scale here this time. Select this. Let me zoom in. Right click. Let's pick a base point. We'll pick this down here. Now watch what happens. Look at this. Look what happens as I draw. See that? It's getting bigger or smaller. Okay? So imagine if you drew that Tetris pattern at 1/4 of an inch increments instead of 1/2 inch increments. You could have just finished drawing it, scaled the whole thing up by a factor of 2. That would have worked, you know. So we'll scale this up, let's say, by a factor of 3. And by the way, these numbers may not match exactly what's in the handout. I'm just sort of flying with it here. What matters most is that you understand the commands more than you're explicitly doing every single thing that's in this handout. So, okay. By the way, scaling works the other way too. Okay. So first off, we can pick a base point that's not on the shape. But what I'm also going to do is pick a value less than 1. So let's think about the scale command. So what the scale command is doing is it's taking all of the dimensions of the object and it's multiplying them by the value that you input. So if you input a value of 3, it's going to make the object 3 times as bigger. What would happen if I input a scale of 1? What would happen? It wouldn't do anything, right? It would just keep the object as is. So by that logic, there are 2 numerical properties that I can think of that probably need to be maintained for scaling factors. They probably need to be positive. What else can a scaling factor not be? Maybe 0? Would a 0 scaling factor make any sense? It would just make the object go away, right? Theoretically. So we wouldn't want zeros and we wouldn't want negative values. So, but what we can do, we could shrink an object. If I put a scale factor in of 0.4, it'll make the object, excuse me, 40% as big as, we want. Can we use a reference for scaling? Absolutely. So we'll do a scale, select the object, let's pick this value here, and then instead of entering a value, what we'll do is we'll use a reference. And so the idea for a reference is we'll say, I want to take this distance and make it that distance. And so that works as well there. And by the way, you can scale one object or bunches of objects. For example, I could go back over here, and this works with all these commands, by the way. I could go back here to this mess with copy, and I could say, let's scale all this. See, I'm scaling all of it, I could rotate all of this. I can rotate all of it. These modification commands aren't limited to one object at a time. Okay? You can do it with as many objects as you want. Okay. Is everybody with me on scale? All right, how about mirror? Okay, watch this. Let's say I want to create a mirror image of this square. Maybe what I'll do is create a mirror image about the left edge. And now what it does is it creates a copy of that reflected about that edge. It also asks me if I want to delete the source objects. In other words, I took an object and I mirrored it. Do I want to keep the original object or get rid of it? Usually most folks, I think, end up keeping it, so we'll say no. There we go. By the way, the mirror command works if the mirror line is anywhere, right? So I could do this, and look what it's doing. It's reflecting the object about the line that I'm drawing. Does that make sense? Any questions on mirror? I don't want to go too fast, okay? Are we doing good? Doing good over here? Okay. All right, let's go down here. This is a favorite of mine. I use offsets all the time. The offset command, so here's what I want you to think about. I want you to think about the Tetris pattern that I had you do. Between offsets and trimming, I could have done that Tetris pattern as probably 3 times faster than anybody else in here, even if you had CAD experience, if you weren't using those commands. So, okay, let's take a look at how the offset command works. Now, I want to show you what I've got here in this. First off, notice here that there are 2 stars. Does everybody see the 2 stars? Okay. I have these stars drawn in a very specific fashion. This first one is a polyline. So AutoCAD treats that as a single object. Whereas here, it's 10 separate lines. Okay, does that make sense? So that matters when we start using the offset command. So let's use offset. So the best way of describing offset is to just use it. So let's create an offset. So the first thing you have to do with offset is you have to specify a distance. Okay? Now you could draw that distance on the screen, or you could just numerically input a value. We're going to numerically input a value of 0.25. You can see here it tells us that there on the screen. And watch what I'm going to do. I'm going to click the star, and then I'm going to click outside. Does everybody see what it did? It created a parallel pattern star offset a quarter unit away. And I could keep doing that. Say, here's another one. Here's another one. Here's another one. I could just keep on going, right? I could offset inwards as well. I'll show you what happens here in a bit, something to watch out for when you offset inwards. Okay? Now, here's an advantage of polylines. Look what happens over here. Watch what happens here when I offset this object. See, when I do this, it's only doing a line at a time. See, so like if I do this, I've got these intersecting objects that I'm going to have to deal with at some point that I didn't have to deal with the polygon. Okay? Does that make sense? Is that everybody okay with that? All right. All right. Now watch up here. Okay. Now this spot here, I call this the disappearing curve. Okay. Let me show you why. So I'm going to hit escape, get out of this offset command, and I'm going to do offset. And I'm going to offset by a distance of 0.5. Okay? Now watch what I'm going to do. Okay? I'm going to take, now let's take a look at this object. This is a polyline, but notice how there's this rounded edge, right? So what I'm going to do is I'm going to take this, I'm going to offset inwards. Is the rounded edge still there? Yeah, it's still there. What happens if I offset inwards one more time? Now it's gone, right? So I believe this curve had a radius of 1. So if you offset inward, it's going to have a radius of 0.5. Offset in again, it's going to have a radius of 0. That radius is gone. So if I keep offsetting inwards, there's no curve. But now watch what happens if I take that object and I offset outwards. See what I mean when I say the curve disappeared? Right? Because I offset inwards to the point where the curve went away. So if I take that object and offset, there's no curve. Okay? So you just need to be careful whenever you're using offsets to ensure that the command's being used appropriately, and that really the big issue is that you're retaining all the geometrical features that you want. Okay? Does that make sense? All right, does anybody have any questions about this? Okay. All right. Okay. Trims and extends. These are really, really powerful commands. Okay? So the way that trim and extend works is it does just what it says. Okay? Now first off, I should mention trims and extends are inverse operations of one another. So, by the way, so what that means is, let's say you're executing the trim command. You're in the middle of executing the trim command. If you hold the shift button as you're trimming, that will execute the extend command. Okay? So, for example, I've selected trim. If I hold shift, it will act as the extend command. Well, let's do trim first. Okay. AutoCAD has gotten a lot better over the past few years. When I learned the trim command, it was a multi-step process. Now it's pretty easy. So the way that this works is, let's look at this single trimming edge. So what I have here is a series of purple lines crossing this line right here. Let's take this purple line and say, I just want to get rid of that. So all I have to do is click the line, and what AutoCAD will do is delete everything up to the edge of that object. Okay? So it will just delete everything up through the edge of that object. Okay? If I've got multiple trimming edges, so let's say I've got, this purple line, I've got all these sort of like, rayed white lines here. What I can do is just click here, and like what it'll do is trim everything between those edges, right? So this is a great way of, for example, doing that Tetris pattern. Here's how I would have done the Tetris pattern. I would have drawn a horizontal line, a vertical line. I would have used the offset command to turn it into a grid, and then use trim to trim out what my Tetris pieces look like. Lot faster than drawing each little Tetris piece. So that's the kind of stuff I want you thinking about as you move forward. Like, are there better, more efficient ways of drafting these objects? Okay? Now, how does the extend command work? Okay? Well, first off, if you want to extend, you can hit escape and actually just type out the extend command, or you can just hold the shift key when you're using trim. What it will do is it will extend to the next object. So right here, extend. Why is it getting angry with me right here? Why is it getting angry? Why won't it let me do that? Because in order to extend out here, it'd have to go past where the line is. Does everybody see that? So if you try and extend this purple line, it'll get angry. It won't like you. Okay? What about if you have multiple extending edges? Just keep clicking. Click, click, click. What about right here? Click, click, click. It'll even recognize the purple line that you've already extended. You just keep on clicking. Okay? What about if you have an arc? So what the arc will do is it will extend along the center of that arc to the next edge that it can find. You can go a lot faster with this stuff. All right, any questions over here? Any questions over here? Everybody good? All right. Two more objects. Okay. Fillets and chamfers. Okay. So what is a fillet? A fillet is essentially a rounded edge. So we'll do fillet with a radius. So it asks for a radius. We'll do a radius of, what is that for, 1.5? Then what do? Select the first line, select the second line. And see what it did? It immediately figured out the arc that would be tangent to both of those edges with a radius of 1.5. It is such a common thing to draw in engineering schematics that we'll just click, 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 click. Pretty fast, isn't it? See how that works? Now chamfers, if fillets are rounded edges, chamfers are primarily meant for beveled edges. Although for a chamfer, you could also have like a zero chamfer, and it just takes two lines and finds their intersection. So for example, if we run a chamfer, so first off, whenever you run the command, look at the very bottom, it should tell you that your current chamfer distance, it should by default say the two distances are 0. Okay? So I'm going to leave that as the case and just click a line, and it will just connect those two. Okay? But if I want to create a beveled edge, let's do a chamfer with a distance of 1.5 on each side. So do 1.5 twice. So it'll, on the bottom, it'll say specify the first distance. Do 1.5, press enter. It'll ask you the second one. 1.5 and press enter. And now what I'll do is I'll check this and this. And now you can see what it did is, instead of joining the lines, what it did is it created an angled edge such that the distance was equal to 1.5. I can do that across every corner as well. Another thing I can do is an unequal distance. So for example, let's do the first line. So we'll do D for distance. The first line is 1.5 and the second distance as 0.5. And so if you do a chamfer there, you can see what it did. It made one edge have a longer bevel than the other. I'll level with you. I really don't use unequal chamfers all that much, but it's an option if you need it. Sound good? Yes. Oh, so it does escape. What I was, oh, that's a good question. Okay. So the question was, like, you're basically asking how do I keep doing it so fast? So here's what I did. Watch this. So if you just right-click in the screen, look what the first thing it does. Repeat chamfer. So if you right-click, that's a really quick way of just repeating the last command that you did. So a fillet command is what I would call a terminal command, where you execute it and it's done. Like the copy command doesn't work that way. You can keep on copying forever. So for like fillet, I would create it and then just right-click and redo it. That's a really good question. You can, yeah, you can. I'll say this, I don't really do that much in practice because I find myself, at least for the stuff I draw, I'll do a fillet here and there and then I'm moving on to something else. So that's always been sort of the way I do things. So, all right, one more thing and then we got to move to text. Everybody good for arrays? All right. So let me show you an array. There's two different arrays that you can do in AutoCAD. There's a rectangular array, and then there is a polar array. So I'm going to do array rectangular. Hold on, if I can spell. Array rectangular. Okay. So the way that works is you select the object, right-click, and then you should get like a toolbar that pops up that looks something like this. So what AutoCAD will do is it will create however many objects you need to create along the x-axis, however many objects you need to create along the y. The default should be something like 4 by 3. And so what we're going to do is change that to 5 by 2. And by the way, I think the handout also says, gives you instructions for if you wanted to change the distance. Like let's say instead of 3 units between, we'll make, I don't know, 6 units between. Maybe this, make that 4. You know, however you want to control that. One thing I'll tell you is that it should ask you for columns, rows, and levels. Leave the levels as is because the levels is 3-dimensional. That's if we're arraying like in and out of the screen. We're not going to worry about that. But if you wanted to, that's how you would do it. All right. For polar arrays, so if we do an array polar, what we're going to do is we're going to select this object. So what I'm doing, so just so you're aware, what I'm trying to do is sort of like simulate what a gear might look like. And so what I've done is I've drawn one of the teeth of those gears, and now I'm going to repeat it across a circle. So we're going to right-click. We're going to select the center of that as the polar, or as the center. What it's doing is it's doing 6 objects by default. I think I need 16 of them. So we'll do 16 tab, and then just close, and then there you go. I mean, it's pretty straightforward. I'll say this, you could, like by default, the array command for polar will by default fill an entire circle. You could say, well, I don't want it to fill the whole circle, like we'll do 16 objects, but only across half the circle, but I don't think that's really common in most practical settings, okay? All right, any questions? Sound good? Okay, I'm going to go ahead and move on to the next drawing, which is covers the two things we haven't yet talked about, at least for this lecture, which is text and plotting. Okay? So, everybody should have a drawing up now that looks something like this. This is a locator part drawing that we're going to basically fill with some text and we're going to plot. Okay? Now, a couple things that we need to do for this file, okay, and I want to do this now, is I want to set the limits. Okay, so I'm going to do the limits command, and I'm going to do 0, 0, and 17, 11. Now, we've been doing this for the past few lectures. Today, you're actually going to see why we're doing it. Okay? Now, text is a pretty straightforward creation in AutoCAD. The first thing I want to do, though, is I want to change the text style. Okay? In other words, the font that we use. And what I want to do is I want to change that font. So if you type in style and press enter, that brings up the text style box. Should look something like this. I want to make sure, so I can put it on any font that I want. I want to make sure that the font is set to Roman S. If it's not set to Roman S on yours, change it to Roman S. Roman S is probably one of the most ubiquitous fonts on engineering schematics, period. Okay? So we're going to use Roman S in this class unless otherwise noted. Okay? So we'll hit it, now that it's on Roman S, we'll just make sure, hit cancel. We're good there. Okay. Now, how do we create text? Okay? Now, I want to be clear, the command to create text, you would think it's text. It's not. It's mtext. Okay? The reason why it's mtext gives you a lot more control over formatting. Okay? So what we're going to do is, the first thing I'm going to do is I'm going to create this stuff here in the bottom, in the title block region. Okay? So let's do mtext. Okay. Now, as you notice, I've got 4 boxes here on the bottom. So I'm going to start with this box up top. Now, I could draw just a box from here to here and just start typing, but I want to do something. Okay, so I'm going to click this first corner, and when you click this first corner, look what happened. You've got all these different options. Height, justify, line spacing, rotation, all sorts of stuff that we can do. Okay, what I want to do is right now, I want to change the justification. So I'm going to hit justify. And notice how there's a lot of different things. So TL, TC, TR, ML, MC, MR. Anybody have any guess what those mean? Top left, top middle, top right, middle left. I want to do middle center. So I'm going to do MC. Press enter. And now what I'll do is I'll select this bottom corner right here, and now I can start typing. Okay? So what I'll do is all caps, by the way, remember engineering drawings are in all caps? Maybe something like that. Put my name in there. And then what I will do is highlight the name and Control U or click the underline button up here, whatever's easiest for you. And then when it's all said and done, close the text editor. And boom, I've got my name there. Okay? All caps, by the way, don't forget that. And remember, your justification needs to be MC. Now, I'm lazy, and so I always tend to look to the easiest way of doing a given task. So instead of repeating that text command over and over again, I like what I got here. So instead, what I'm going to do is use copy this object down, and then copy this object over. And what I'm doing is I'm copying from base point to base point. So I'm using the corners of those rectangles as the base point. And so now all I got to do is just, edit the text in here. And so how do you edit text? Just double click it. So this one right here needs to be date. And we'll say today is, we'll say this one right here, what's the title? This is a locator part. And this is sheet 1 of 1. One of 1, not or. I'll give everybody a sec on that. Yeah, use the MC on the text, all caps. We'll see a couple lowercase letters. All caps. Engineering drawings are in all caps. Yes. What's that? All about what you use as your information. When you're creating, click the top corner, then J and C. And do that before you click the bottom corner. How we doing over here? Everybody good over here? Good over here? All right. Just to get a little bit more practice on the text command. So let's create a text box up here. So mtext. We'll place it at, so now we'll start inputting some values. So 10.5, comma 10. We'll do, let's see. Now, okay. So this text box has a lot of different features. What I tend to recommend whenever you're doing text boxes is if you're going to numerically specify stuff, specify the width last. Okay? Specify the width last. So what do we need to do for this text box? Well, it says here we're going to do a text height, so a height of 0.2, a justification of TL, and a width of 4. And now we can start typing. And what do we have here? We say, note, this text box was placed at 10.5, comma 10 with a width of 4.0, a text height of 0.20 was used, top left was employed. And so your text box should look something about like this. If you don't use mtext, sometimes it can get angry at you when you're pressing enter. So, all right, we're running short on time, so I'll stick around if anybody has any questions on text, but I really want to show everybody plotting, okay? But one of the things we have yet to discuss is how to generate printed drawings. And so we're going to generate drawings to PDF, okay? So let me show you how to do that. So we're going to print, or plot. You can just type plot, or you can click the printer button. Then you get all this. Now, just so you are aware, you can click OK, and like once you pick a printer, and it'll give you a print. But it won't be correct. And by correct, it won't be bounded correctly, and it won't be to the appropriate scale. Okay? So what do we need to do? We need to change some settings. Okay. So a couple things. Number one, up here where it says plot style table, we're going to change it to monochrome. So what that does is that makes all the lines black and white when you actually print it. So that removes the color of the layers. We're going to change our printer to this one right here, DWG to PDF. Okay? Now, what are we going to do for paper size? This is on an 11 by 17. So we're going to go down here to 11 by 17. And we're going to pick the one that's full bleed. Okay? Full bleed means that AutoCAD will literally use every edge of the paper, which is what we want because we specified the limits of this drawing as 17,11. By the way, what do we want to print? We don't want to print the display. That's what's on the screen. We don't want to print the extents. The extents is just the limits of all the objects. I want to print the limits. Now, if you've done this correctly, it should say that the scale is 1:1. If not, you can uncheck that and make sure that's 1:1. Center the plot. Then when you hit preview, boom. Looks exactly the way it's supposed to. Okay? Now, if you're using Cameo, what you're going to have to do is save this to your MS drive. But when you hit print, because you're printing to a PDF, you could just save it, I don't know, on the desktop. And boom. Your PDF should be done. Does anybody have any questions on that? I know I did that kind of quickly. Try the printer. No. DWG PDF. Where's your hand up? All right, I'm going to stop the recording and pull the QR code up again. If anybody wants to stick around for a couple minutes, has any questions, I'll be here.